So let us take one more closer view of the given problem. If you see in Z plane and in W plane, let's say the cube root of unity we have already seen. So if we see Z is lying between 0 and 1, right? Z lying between 0 and 1, and then in that case, I want to know where is my Z will be. So Z will be like here. If you see 0 and 1 means X is lying between 0 and 1, right? Because no complex part, right? So here the line will be here. Okay. So if I'm going to find the cube root of unity, uh, cube root of unity, right? W equal to cube root of unity, then what will happen here is we are going to see the sheets, right? So if you see here this sheet and then 60° we have seen 60°, right? So we are going to see 60° rotation, right? And then 2 pi by 3 and then 2 pi by 3, right? So what had happened here is this is 2 pi by 3 rotation, right? And this is going to be again 2 pi by 4 pi by 3, and this is 6 pi by 3, right? We have already seen before. Okay. Now the question here is if I am going to move, let's say alpha angle, right? You got it? Alpha angle if I am moving in Z plane. What net effect would happen here is we are going to move again this alpha angle here, alpha by 3. Then again we are going to move slice like this alpha by 3, and then we are going to move like alpha by 3. So basically I'm going to get this sheet, these three sheets, right? These three sheets, right? If I move completely as we have discussed, so this is how we can see the three Riemann sheet can be prepared, right? And if if alpha lies between 0 to 2 pi, right? That we have discussed before, 0 to 2 pi. So what will happen? This will become your Z plane become like this, right? What will happen? It will be like this and this, and in that case this, right? So in that case you are going to get the three sheets as we discussed before, this and then this one, this sheet, and then other one is this, right? So this is how the function is going to take the single valued in each sheet, and where all the the boundary, if you see these are the branch line from one side. If you see the function has different value, other side is function has different value, so this line is known as the branch line, right? And where all the branches are meeting is known as the branch point that we have already discussed, right? So this is another observation. Thank you very much, thanks a lot, and we will see some more problems on roots of complex number in the next video.